Hi everyone, welcome back to Online Learnings. In this video, we'll be discussing about network protocol suites and TCP/IP protocol in detail. Before diving into the topic, please have a look on the previous questions in the previous video, and the answers are on your screen. You can all pause and match your answers with the answers given. So let's get started with network protocol suites. So the definition given here is a group of interrelated protocols necessary to perform a communication function. In the previous video, we discussed there are a lot of protocols. There are rules for communication, then there are rules in order to secure those communication. So all those protocols together form network protocol suites. And the first one is Internet Protocol Suite or TCP/IP suite. It is an open standard protocol suite maintained by IETF. And the second one is the Open Systems Interconnection OSI protocols. I hope everybody have heard about OSI protocols. These are the very first protocols made, and after that TCP/IP protocol came. So OSI protocol include a 7-layer model called OSI reference model, and it is replaced by TCP/IP. As I said, TCP/IP came after OSI model protocol. So the third one is Appletalk. It was short-lived. It was released by Apple, but Apple also afterwards adopted TCP/IP protocol because it was a very interesting and good protocol. Then there is the fourth one, Novel Netware. It is also same short-lived protocol and network was developed by Novell Incorporations, but they also adopted TCP/IP protocol. Now we'll have a detailed discussion on TCP/IP protocol. So the TCP/IP protocol, the rules of TCP/IP are available in 3 layers, which are, let me highlight, which are application layer, transport layer, and internet layers. That doesn't mean that there is no network access layer, because network access layer means the physical transmission of data, like through wires the data is being transmitted, and there is no such model which will not include the network access layer. Every model, because if you think also logically, whatever is the case, there has to be some medium present in order to transfer the data. So the network layer deals with the medium which transfers the data. But TCP rules are not included in that network layer. TCP rules, TCP/IP rules are only concerned with application layer, transport layer, and internet layer. But that doesn't mean there is no network access layer. There is network access layer. So it's very important point, and often students mistake. Network access layer protocols are responsible for the delivery of IP packet over physical medium. So let me clear, when data is passed in the physical medium, it's called IP packet. Okay, and Ethernet and WLAN are its examples. So the mediums which I was talking about is Ethernet, it's either wires, or WLAN or wireless LAN. So there has to be some medium through which the data is transferred, but TCP/IP protocol is not concerned with that. It is only concerned with application layer, transport layer, and internet layer. So this is a diagram of TCP/IP layers. As you can see, the protocols which I was telling are only concerned with the 3 layers: application layer, transport layer, and internet layer. The fourth layer, network access layer, exists, but TCP/IP protocol has nothing to do with that. This diagram, you can just copy it, and we'll be discussing each layer in detail in this video only. Talking about application layer, as we have seen before, TCP/IP protocol is concerned with application layer, and in this slide we'll be discussing about name system. So in name system we have, first is DNS. So DNS means domain name system. It translates domain names into IP addresses. Now what I mean by this is, suppose I want to go to google.com. What I'll be typing? www.google.com, right? But the computer automatically translates into ones and zeros. It's easier for us to remember Google than ones and zeros. That's why this system comes in place. Because at the end of the day, whenever we have to research something or anything, we can't remember numbers, right? So we type in English and the system automatically translates into the required format. So because the system won't understand English, right? It only understands ones and zeros. So it automatically translates www.google.com into some binary number. The next one is host configuration. But before I go to host configuration, I would also like to mention here, like, how is the system able to convert this? So there are some tables which are stored in the system, and in those tables there are like rows. If I say www.google.com and adjacent to the google.com there is an IP address. So the system checks google.com and directly points it to that IP address. So there is a mapping in the table, because otherwise how would anyone remember? There has to be some memory storage related to this, right? So the next is host configuration. DHCPV4. DHCP server, or what it does is, now it is also a server which dynamically assigns IPv4 addressing to the clients at startup and allows addresses to be reused when no longer needed. So what happens is, whenever you buy some computer, right, and you want a computer to be in a network, to have to access the network, to access Google, to access Facebook. So whenever you on the computer, this there must be a server nearby your location, or in the ISP offices, which dynamically means automatically it assigns IP address to your laptop or computer at which you are working. And if in case after 30-40 years you are not using your laptop, that IP address will no longer be of your laptop. That IP address will be assigned to some other computer. IP addresses are very important because, as I said earlier also, if you know the address of a place, then only you can reach there, right? Similarly, if you want to reach Google, you need to know the address of Google. And in the same case, if Google wants to give you some information, then it needs to know your address also. That's why IP addresses are very important. And DHCP server is the server which provides IP addresses. And if it is V4, that means version 4 server, it will provide IPv4 addresses. If it is version 6, V6, then it will provide IPv6 addresses. Because there are two kind of addresses, IPv4 and IPv6. The only difference between these two addresses is the number of bits. We'll be discussing it later. But right now you only need to know that DHCP server gives you an address. Okay. And the next one is SLAAC. It is called stateless address auto configuration. It allows a device to obtain IPv6 addressing information without using DHCP v6 server. So this is such a device in which you do not need DHCP server. You can automatically get the address of IPv6 from without using any DHCP server. You can automatically get it. Right now we are not going into details like how it happens or why it happens. I know you must have so many questions about how is it possible, but because there is a lot of research and uh, lot of uh, lot of knowledge has been exchanged in order to develop such a system. So right now we only need to understand what the system does, and after that we can go on to how it is built and how it functions. So we are done with name system, we are done with host configuration. Now we are up to email. So email, first one is SMTP. Its full form is Simple Mail Transfer Protocol. So we are transferring mail, right? Simple Mail Transfer Protocol. If you think the names are very difficult, don't worry, you will be able to learn them eventually. So right now you're transferring mail, okay, and there are some rules. So what this it so these rules are nothing just softwares developed inside a system so that you can perform certain functions. So what this does is SMTP, it sends mails to the mail server and enables servers to send mails to other servers. So what it does is it sends mail to the servers and make sure that that server also sends mail to another server. So the whole programming is only related to how a mail is sent to another server. The next one is POP3, which is Post Office Protocol version. As the name suggests, post office. Like post office means you need to send messages, right? So what it does is it enables client to retrieve email. Retrieve means to have email. Post office, what is the work of post office? Mail has been delivered to you, you just need to pick it up or someone will give it to you, right? So the thing is, you are receiving the mail, you are retrieving the mail from the mail server. So POP3 it does is you retrieve mail from a mail server and then you can download it also to your to the client's local mail application. So you have email application like email app. Nowadays you use Outlook, Google, Gmail. So POP version 3 makes sure that you have that mail and you can download it only on your application. You cannot download it on your what do you say, laptop or something. You can download it on your application. So like all these things are ways of receiving mails, but they differ in some context, right? The third one is IMAP, Internet Message Access Protocol. So what it does is now you can retrieve on your laptop. So it enables clients to access email stored on mail server as well as maintaining email on the server. Um, we can't say that here you can't download it on your mobile because eventually you can in a way. But what I'm trying to say is all these are different layers put on email. The first one says you can send the mail to the servers. The second one says you can receive the mail. The third one says you can store the mail and you can maintain that mail. So these are like different layers given to the email functionalities. There's nothing rocket science right now because we're not going in detail because we're not into making a software like how it's happening. That's the software part. Right now we just need to know that there are some layers added on to email. This is only application layer going on. So there is so much layers on application layer. There is DNS, host configuration, email. Now we have reached to file transfer. Okay, so now we are transferring file. It's easy. We know that we need to transfer file to the destination and then the destination receives the file. But what we are trying to make you see is that there are some protocols and it's not like in one single go everything happens. There are some layers and then a proper function is performed. So coming to FTP, File Transfer Protocol, it set rules to access and transfer files. I'll use this. It takes files to and from another host over a network. So there are some rules which are being followed if you have to access the files, if you have to transfer those files over the network. Now, by these rules, I don't mean that oh there are some restrictions. No, they're not. They're not kind of restrictions. They are kind of ways how to transfer file from one network to another network. So these rules are generally ways of transferring things. So there are some ways by which we can transfer files from one host to another host over a network, and FTP is a reliable, connection oriented and acknowledged file delivery protocol. So what do we mean by these three terms? Reliable, connection oriented and acknowledged. So whenever you send a file, so what happens is, it ensures, if we use FTP protocol, it ensures that your file will be transferred to the another host. It is sure, like there is no way that your file will not be transferred. It will be transferred. But before that transfer to happen, there has to be a connection created between one host and another host. So how it ensures, how it is so confident that the file will transfer? Because firstly, this laptop or this end device will say, hey, I want to transfer a file. So this is one. This says, yep, okay, you can do that. This is two. And then it sends its file, and then it says, yep, received it. So in this way, acknowledgement of file that it has been received is sent back to the first end device. So our connection is created, it is reliable, you can trust this connection, because the file, if it would have said that no, you can't send me file, then it's okay, then it's logical that the other end device is not ready to receive a file. But if it says that yes, you can send me file, then the file will be sent. The next one is SFTP, SSH File Transfer Protocol. So it is an extension to Secure Shell Protocol. So what we are doing is, we are still accessing files, but in a secure way. So here what's happening is, used to establish secure remote login for accessing command line of device. So whenever you log in, and whenever you log in into a system, you want, because why do you log in into a system? Because you want to have access to some files, you want to see it. So what SFTP does is, it makes the whole situation or whole environment secure enough for to avoid any corruptions or any uh, unwanted um, disturbances. The third one is TFTP, Trivial File Transfer Protocol. It is very simple, connectionless file transfer protocol. FTP was connection oriented, it is connectionless. With best effort, unacknowledged. FTP was acknowledged, it is unacknowledged. So what happens is, this also sends files, but it does not make a connection with another end device. It just sends file from its end. Whether the end device receives it or not receives it, TFTP has nothing to do with that. TFTP will say, I am sending you file. You want to take it, you take it. You don't want to take it, you don't want to take it. It's your choice. If it doesn't reaches to you, then also it's not my problem. But I will be sending you files. Okay, so this is TFTP, and it uses less overhead than FTP. What that mean is, now there are not more steps in TFTP, like unlike FTP. In FTP we had, first I will say, hi, I'm sending you file, then the another end device will say, yep, okay, send it, and then FTP will send, and another device will say, yep, receive. But in TFTP nothing happens like this, so there is no extra overhead. Coming to the last one, of application layer. So this is web and web services. In application layer only, because we use web, right? Everyone use web, so it is a very important one. So first we have HTTP. So HTTP protocol, or hypertext transfer protocol. So what it does is, there are some rules when it comes to exchanging text, graphics, and videos over internet. So those rules are defined by HTTP protocol, which needs to be followed. Then we have HTTP secure. Now it's the same thing. You are sending data, you are exchanging text, you are exchanging graphic images, but in a secure way. So it encrypts data. So what happens is, if the data is like, suppose this is line and data is transferring from here, right? And if some another person tries to hack into the system, even though he can see these bits, but he would never know what these bits imply, because they're encrypted. Encrypted means there are some functions, there are some algorithms which make sure that your data is mixed. If I say web, so it might be written as EBW, and then there might be an algorithm which would make EBW into WEB. So encryption means it's a way of securing data so that another person cannot understand what is sent over the network. The next one is REST, representational state transfer, a web service that uses application programming interfaces and HTTP requests to create web applications. So what it does is it knows it has some rules which uses application programming interfaces and HTTP requests to create web applications. After completing application layer, now we are up to transport layer. So transport layer, first we'll discuss about connection oriented. As I said before, also connection oriented means, okay, here in FTP I discussed connection oriented, if you remember, right? So TCP, transmission control protocol, it enables reliable and acknowledged communication. As I said, there is one device and there is another device. This device will say, can I send you something? This device will say, yep, send it. Then this device will send something, and then this device will say, yep, received it. So this is a connection oriented, and this is acknowledgement, like yes, I have received it, I have received it. So this is the whole reliable system, because in here we know that the transmission of data is definite. So therefore TCP enables reliable and acknowledged communication between different hosts and confirms successful delivery of transmissions. Now comes to UDP, it is connectionless. So all these things does not happen in UDP. No. UDP stands for User Datagram Protocol. It enables communication but does not confirm its success, right? After application and transport layer, we are up to internet layer. So talking about internet protocol, IPv4, IPv6 and NAT NAT. So IPv4. IPv4 is Internet Protocol version 4. So what it is? So every end device, every intermediary device has some address, okay? Because we need to know where it is situated, who is sending, who is receiving, and in order to make sure that, okay, let's say postman wants to deliver a message to your house, he should know your address, right? So in a similar way, when we are sending messages, we need to know the addresses. So IPv4 is that address and IPv6 is that address. These addresses are transferred across the network and then the data is transferred. So IPv4 or Internet Protocol version 4, it receives message segments from transport layers. So what happens is, now we had this application layer, uh, and then we had transport layer, and then we had internet layer. It is logical, right? In order to, because this all ease out the process of understanding. So what happens is, from IP layer, the data is transferred to transport layer. For transport layer, what it does is it also like encapsulates some protocols on the data, and then that data passes on to internet protocol layer. And internet protocol layer does is it receives that message from transport layer and it covers that packages them into packets. So if I say I want to send some data from internet layer, I would say that data is called packet, okay, because it is now in the form of packet. That data has some extra information included. Like I said, if there is a letter and it is covered with an envelope, and that envelope is an extra information, right? In a similar way, in internet protocol layer, the data which is received from transport layer is packaged and converted into packets. So these packets are 32-bit addresses. So what they are converted into? Addresses. And the packets, inside the packets there is data. The packet outside the data, it is address. So that whenever you shift that data packet to across the network, it can see the address outside only. It does not have to search inside the packet, right? And then IPv6 is also similar to IPv4. It is the same thing, but it is large address. So if IPv4 was 32 bits, IPv6 is 128 bits. Then there is NAT, Network Address Translation. It translates IPv4 addresses from private network into globally unique public IPv4. So what is, as we read, there is intranet and there is extranet, right? So these are private networks, and that is a global network. So these networks are translated to enter into the global network, because global networks don't know that these IP addresses exist. They have no idea. And in order to go inside the global addresses network, they need to be changed. They need to be translated. That's why NAT and translates these addresses from private and they made it public so that everyone can see those addresses. Coming to the messaging of the internet layer only, we have ICMPv4. It stands for Internet Control Message Protocol. It provides feedback about errors in packet delivery. So when packets are sent from destination to host, if there is some error in the packet during transmission, ICPMP protocol helps to figure out what that error is. So it provides a feedback that there is an error, the packet can't be transported, and it, because it's v4, that means version 4, so it tells errors about IPv4 addresses. If it's v6, then it tells errors about IPv6 addresses or packets. And then there is ICMP v6 ND. ND stands for neighbor discovery. It includes 4 protocol messages used for address resolution and duplicate address detection. So what it does is it has some other protocols which are used for address resolution and the duplicate address detection. Then the next is routing protocols. So here I have mentioned 3 routing protocols and their full forms, but since I have not gone into detail about routing, and there is no need right at this stage, but you should know that routing um, is a way to send packets from one network to another network. But routing protocols make sure that that packet is sent in less time and with ease, without any collisions, without any errors. So this is the purpose of routing, so that we can send packet very fast to all the networks which we want. And now we have network access layer. As I said before, this layer does not include TCP/IP protocols. This layer is by default present, obviously, because this layer deals with transmission of data in the way of bits, right? Because at the end of the day, even if you are sending a packet through wires, that packet will be sent in the form of ones and zeros. So what is happening is application layer has some data, if and then it is converted into uh, transport layer data, because transport layer understands some different language. So application layer data is transferred into is changed into another form of language, you can say, and then from transport layer to internet layer. And internet layer has packets, the same data is known as packet, but the data or has another functionality, which that's why it is known as packet, right? Because it is encapsulated, and it got addresses IPv4. And now in network access layer, that packet will eventually go in form of ones and zeros, right? So first is address resolution or ARP protocol. Address resolution protocol provides dynamic mapping between hard IPv4 and a hardware address. So this, what happens is, now we can send data in form of IPv4 addresses, because IPv4 are numbers like 1, 2, 3, 4, which only we understand. But computers and another computer and the wires, they only understand the language of ones and zeros, or a voltage up or down, right? So what is happening is that IPv4 addresses are logical addresses which we have created for our own ease. But there is a mapping between IPv4 addresses and network and hardware addresses, because the address which your computer has got is not an IPv4 address, it is a hardware address, it's a MAC address, right? So if I say this one address is linked to A, and one I will understand, but A computer will understand. So I'm sending one, computer will change it into A and then transfer it to destination, because A is understood by everyone, by computers. So this is happening here. The second is data link protocol. Now what's happening is the linking of data. Now here comes Ethernet and VLAN. So now what's happening is that hardware address which is sent, which is A, now is in the form of ones and zeros, right? And its up voltages up and high. So for the rules of wiring and standard signaling, all this comes under data link protocol. And WLAN is wireless area network. So there are some rules of radio frequencies when it comes to not using wires. So all these protocols are ways of sending data, but in their own unique way. So these are some questions I would like you to try. And one more thing. So the question fifth question I will be discussing in more detail in my next video, to have more clarity on the topic. So you all can pause and try to figure out the answers of all the questions. Thank you for watching this video. Please like and subscribe to Online Learnings for more such videos. Thank you.